table type that can deal with both analytical access for OLAP, online analytical processing, and OLTP. So today, the company is some 100 million plus US dollars in annual recurring revenue, ARR, okay, and over 350 global customers. Usually we show some slides about now, and I complain bitterly that we haven't updated them. Today I'm having to do without any slides, so I'm just doing it from memory, but we will get those slides updated in due course. And so architecturally, I mean, the product at its heart is a relational database engine, and it is capable of multi-model, okay, support. So it has support for JSON, for example, geospatial, time series. Vector support has been in there for some time, actually, quite a few years. So we are not a company that has just added vector support. It's already been there for some time. But earlier this year, we did announce some major innovations and improvements to the vector support. So indexing, for example, a dedicated vector type, rather than having to store your vectors as blobs, for example, and approximate nearest neighbor search. So these were sort of very, very useful. We've covered them in some previous webinars as well. And we have integrations with a wide range of other tools and technologies as well, such as Apache Spark, Apache Kafka, for example. We work on all three main cloud providers in the Western world. That's AWS, Google Cloud, and Microsoft Azure. Can use it in a Docker container as well. There is the opportunity to install it on-prem. But with the links that Yukti will share with you, okay, you can register and be up and running in a couple of minutes, okay? So the free account, which I use now extensively, okay, the free shared tier. I was just talking to my colleagues a little bit earlier on, the growth engineering team, and I was sharing with them my experiences that, previously I choose the standard tier, which kind of burns through credits, even though it's not very much, sort of 0.25 to 0.28 credits per hour. You can make your credits go a very, very long way. But the free shared tier is always on. It's pretty awesome. Okay, and with that, I will stop there, okay, because I think Yukti will probably share some links with you in the chat, and I'll step down now and to assist her with the Q&A. Okay, so please keep your questions going, and we'll do our best to answer them. And Tom will talk you through, and hopefully there'll be time at the end. So if there's something specific, so we'll do our best, but we may not know what is specifically on Tom's mind. We'll try and answer the questions to the best of our ability, but we'll try and pick some as well that we can't answer perhaps, and then leave those to Tom to assist. And so over to you now, Tom. Thank you very much.
All right, beginner's guide to multi-agent. Welcome back to the webinar series. So I started with a webinar on beginner's guide to vector databases. I did not expect it became a series, but it has become a series. I've been enjoying thoroughly doing this, working with Yoxi and Akmal, and three of us seem to work together quite well, and we are example of a multi-agent system, which is what I'm going to talk about today. And I am sharing my slides, and these are the blank slides, and they are available at this link. And I encourage you to download them, and you could follow along if you want to, if you happen to have a joint tablet. Okay, and so I'm gonna do is to turn off my camera so I can save bandwidth and then focus on sketches. And then when at the Q&A, I'll turn my camera back again so I'll be able to see you, and you'll be able to see me. All right, so I'll see you soon. But you can still hear me. So I'd like to start my webinar today with a real world example based on this product called Orion. It's by Gravity Foundation, which is in my city, in my neighborhood. So they have a pretty good team and a very compelling use case. So I use this to motivate multi-agent and to give you a real world perspective. And let me see, is this happening correctly? Okay, wait, did I just, all right. So this is where I want to be. Wait. Okay, and so when you like to build thinking about, well, should I use a multi-agent system for my use case? You usually start with what you already have. So if you run a business and you have data, and you probably would have a database and probably run something like SQL and with lots of data, and they might be using single store or some other vendors. And then you have people who, and then on the other end, you have business operations who run your procurement department, buying inventories, or also marketing department, and to buy ads and buy work with the influencers to sell your products. When you look at your own team, you might realize on the data side, you have one analyst, you also have a manager, and that's what you have. And when you think about maybe I could use AI to enhance my team and to optimize my business process and hopefully turn a profit. And you will start with what you already have here, and you will say, well, maybe I could still uh, somehow see whether AI could play the role of an analyst. You could be able to double the productivity, and you were trying to see whether I can describe the analyst with, say, for instance, I say, well, I can give you a backstory. I have a curious analyst, and I also have a manager who is always suspicious of what the analyst might have said. So I can say, I think our manager is quite suspicious all the time. So that's what I started with. And when you build a multi-agent system and such as using Orion, what Orion wants to achieve is that they would like to provide the services will be similar to have a bunch of McKinsey consultants. So McKinsey consultants are very expensive to have, to hire. Wait, why is this doing this? Okay, let me just make sure. McKinsey consultants. Do you like your multi-agent system to work like a group of McKinsey consultants, except that instead of working 8 hours a day, you could have them working 24 hours a day and 7 hours a week. And you looked at this while how you can fill in a blank. So you will probably think, well, I would like to have someone who could write Looker model language, this Looker ML, this expert. If you do that, and you'll be able to write Looker ML, which sits on top of SQL, and they will go to your database, retrieve some data, and then come back with data and generate some reports back. And with these reports, you could hand off to, well, it would be nice to hand off to another expert called Action. And then this expert will be able to recommend things like, oh, well, maybe for the procurement department, so something actionable, let's buy maybe 300 boxes. Okay. Uh, uh, so and then so I apologize that I think the writing experience is not really smooth. I experienced a lot of lag. So fortunately, today I'm prepared. So I actually have a contingency plan. I have second device. So I'm going to stop share and using another device. Hopefully they'll help would be better. Okay, so I have my backup. Okay, so are you seeing another set of slides here? Okay, and then so I'll be able to do this. Okay. And then I would like to do is wait. That's not exactly what I want. Just give me 1 second to jump out of this. Okay, so I think what I'm gonna do is I'm going to write directly on top of this. And where I was at is that I'm trying to say that we're trying to define different agents we need. We'll have this. Oh, this is much better. Can you see my screen? Okay, good. You could action, and then you also the agent, we want to be able to make business advice, like buy 300 boxes to the procurement department, and then but you would like to be able to justify it. So you realize I need another agent to be able to tell me return on investment. And so along with this suggestion, I can say something like, oh, your revenue, projected revenue is up 10K. And for marketing department, the same agent could be suggest action like buy more TV ads. And then for justification, the ROI agent could be saying like, oh, you're gonna increase 50 maybe large clients, and that will be in your report, and trying to just complete this Looker expert. So this is my another agent. Okay. And then with this, we will like the ideas that like you could have them working 24 hours and 7 days a week with some kind of coordination and hopefully achieve the result. Orion is making promise that it could do that. And so anyway, so I want to use a real world example to give you a sense that lots of companies are trying to think about agents and to incorporate that into their business workflow, and hopefully with a idea to increase their profit and to engage with customers more. Now going back to the actual lesson that I like to do today and make it bigger now. So the next section, what I'd like to be able to take you to going from beginning. At the time, we only started with large language model, how we could evolve to RAG, to agent and multi-agent over time. And so let's go back to when we just had the large language model. You're trying to apply this to your own application, and then you will have this user, and the user will submit a query. And for instance, user might say, well, how much are 2 bags? That's what I write for this query. And then we will send this to large language model. I use this to denote my large language model. And you're going to provide some answer. One example of the answer could be, well, you are talking about flour, right? That's my guess, even though it didn't say flour. And a bag of flour is 12, or maybe it's $24. And so how would the language model know how to do this? Because it was trained from the internet worth of data. And on the internet, so there's a lot of data and knowledge on the internet. And then also is a bit more biased toward the global north. So when you talk about a bag of stuff, instead of rice, it's more likely to say flour. So large language model, just as is pre-trained, they were going to use the internet to draw its knowledge. But the problem with that is it doesn't really use your data. What happens? You have your own data and for your own local business need. And that wouldn't work quite well for internet. But we still like to use large language model. Why? Because even though it's trained on internet with someone else's data, because of that, a lot of data, it actually does math quite well. This is what we want. Math, we want it to apply its logic. We want it to perform some reasoning. This is what we like the language model to do, not to hallucinate on data that's not your own. So that's when this RAG comes in. So a little quick review is RAG, and then we still have this user providing the input, but instead of sending to large language model directly, we're going to do an extra retrieval step. So when we retrieve from my database, I have my own database, and I maybe put it in the vector database, and then this is my database. And what's important is that this is your data, not the internet data, your data. And then maybe you run the store, grocery store, and there are a bunch of different stuff. And then the things that could be in bags will be Apple. Apple can be put in bags. So in my store, Apple, I'll put in bag, and then will be retrieve the relevant information from here, add in the context, and $6 per bag. And then I would like to provide some instruction. So, well, you're gonna answer this question, how much 2 bags, but also be kind of brief. Don't be too verbose. Don't say too much. And then after you have that, and you will send this to large language model, and then this is a whole thing. My query and context and also the instruction altogether is this where augmentation occur, and then go back to you, and the compounds to answer in this case, and then based on this, $6 per bag. Large language model perform logic and some math, and the answer is 12. And it's being very brief, doesn't say anything else, just like $12. Okay, so that's RAG. And going from RAG to agent, now have worked out what, as a review, what the RAG is. I would like to put this to show you the contract between RAG and agent. How do we go from RAG to agent? On the left is the RAG, and then we actually put instruction here. And instead of thinking in terms of instruction, for an agent, you're trying to make it more like a human. So, and then you will talk about, well, maybe it's a rule. Instead of saying that instruction, you could think about rewriting the instruction as a role, and then it could have implication. And the language model is being shown that if you just say, use the role, and they could engage some other part of a skill and knowledge and do much better job. So in this case, instead of to be brief, I want to say precisely, I want my model to work as an eager sailor. And so the rule, kind of like when I work with my son and he has messy room, I could give him a lot of instructions saying, oh, you pick up the socks, pick up that dirty laundry. That would be more like rag. But if I see him as a human, I would say you want to be a clean and organized person. So focus on the rule. And then maybe he is smart enough to know that being a clean, organized person, he needs to pick out his dirty sock. So this is the idea, turning from just instruction to an agent, going from and with roles and backstory. So in this case, another thing is that in the retrieval augmented generation setup, and so every time we query, we just send it to the database. But in this case, I like the model, I mean, large language model to actually make decision for us. Maybe you don't always have to look up the price right away. So this is one of the possible action you can do. Another possible action is that since you're an eager seller, maybe you want to find opportunity to upsell your product. So upsell is another opportunity action you can potentially perform. So in this case, when the user provided input, and instead of going to the vector database right away, you actually put the whole thing again. This whole thing is a whole prompt role. In this case, no context yet with query and with two possible actions to choose from. In this case, large language model decided, given all this information, maybe the action is that, well, I do need to look up price. So with that, so I go back to really query the database and look up price and same information. I can get the same information, but instead of pre-programming into the process, we have a large language model decide I want to look at the VR database. And then also being the eager seller, as part of the information provided to the large language model, it will say, well, Apple has opportunity to upsell opportunity possible, and maybe 10% off or something. Some extra information that you could get from your VR database that tie to your businesses. In this case, and then after that, and this whole thing one more time again, this whole thing again sent to a large language model. In this case, now has some extra context. It still knows it's an eager seller, and you have two items to choose from. Now that it knows information, you no longer need to look up price. In this case, large language model will say, well, maybe my next action is upsell. When you upsell, and then also the upsell is that to go back to the user saying that, how about you want to get 2 bags, but I'm offering 3 for $15. How about that? So it's $3. It's like it worked out to be about 10-15% off, I think. So instead of paying $12 for 2 bags, this agent able to act more like an eager seller and to actually offer not just a straight answer about 2 bags, but like 3 for $15. Do you want to take it or not? So this is trying to show you the contract between RAG and agent. And going from one agent, now I want to show you how to then go from one agent to multiple agent, and with a slightly different scenarios. And now we have go from one agent to 2 agent. What is, and again, the process is that, well, now we are this pre-launch, we're trying to develop in this. And then when we're developing this, I want to define my 2 agents. And in this case, going back, I will just focus on very simple business case, like providing some refund. I would like to provide services to handle the refund requests from the customers. So I'll look at what I have. I do have some database I already have. So these are my customer databases. There's, I guess, my CRM. So it knows a lot of my customers. Also have my older system. So these are what I already have before I introduce AI. And now I'm introducing AI. I say, oh, in order to offer a refund, what do I usually have? So I usually like to have the first person to answer the phone. So I want to have a helpful. First row is I want to have a helpful receptionist to pick up phone. And then also I don't want the receptionist to decide on the refund. I would like to give the work to a generous manager. So for some reason, this instead suspicious, I have a generous manager. And then I was thinking about what kind of action or functions or tools that are available for the agent. So for the receptionist agent, so one of the tool is that maybe you can look at who is this calling from customer database. And then if you can handle, you think the manager should handle this, you have a transfer function. I transfer to manager. So this is my to function. And for manager, that could decide, oh, maybe I want a refund, or maybe I want to reply to the customer. And so that two action is available. And then can pick what large language model you want to use. Is OpenAI, or it could be a cloud, and this or Llama, so the decision you make about which large language model. So all this happening at the design development time. We have not put this online yet. So context is kind of dynamic, it's not decided yet. It's runtime stuff. And this blue thing is the user input is also leave it open. Now, uh, so now we finished designing, developing, hopefully, and put it online. So that's what we have. Now putting online, we have actual user. Then I want to work through the actual example case, how this is gonna happen. So say we have a user actually calling in. When I call in, it go into the user input. And what we get is that we have a phone number from this user. Also, and the user say, hey, can I speak to the manager? What the user says, speak to manager. So this is a user input we have. And in this case, if we could pass, then we can now have enough stuff to pass to our large language model because it has a logic to try and play the brain of this agent, who is a helpful receptionist. And how does the large language model know it has to be an agent, a helpful receptionist? Because you pass this whole thing to the large language model. So it knows that it has to play a role of a helpful receptionist. It has received user input, phone number, speak to manager, and you have two options you can do, two actions you can do. Transfer the manager or who. So initially it decided, well, maybe I don't have to transfer the manager right away and wouldn't be too helpful. So I want to look at who the manager is, who this person is. So I use this tool, and this tool is going to engage my customer databases and looked up. Well, turns out this is an important person. It's a VIP, very important person, and his name is Tom. Okay, so knowing that, now second round, you still pass this whole thing to large language model. Now large language model has a slightly more information, knowing that it talk about a VIP and his Tom, very important person. So in this case, maybe I do need to transfer to manager. So when I then will transfer the manager, and when that happen, and I will pass it to this agent. The control is passed to another agent who is a generous manager. And generous manager would, before that we do that, in fact, that I want to pass this information over to the generous manager so have the same context and also user input to work with. So in this case, can use we can use this function to I will select this. Come on, don't do this one. Select this, my sketch, copy and paste, and I'll be able to move. And I move, I'll move over here, copy over here. So I have VIP and Tom. I can do the same thing, but they just save my time. Now the manager has all the information, is going to use its brain, which is large language model, send all this information. And with this, okay, VIP is calling, and I'm generous manager. I have refund reply option. It would be odd that I just reply right away. Maybe I should refund because it's VIP, it's Tom. So they'll decide, well, I need to refund. So when I refund it, and then it will go to our oldest database, not this color. Oldest database this time. And the order bad is going to return something being, okay, well, I'm returning you to $120. That's the product you bought last time. And with this case, and then we send it to a large language model, and it says, oh, I have everything I need. It's refunded, $120. I think we are ready to reply to our customers, and then they will complete this transaction with the user with the multi-agent system. So there's a few things that like you see is happening. That we'll have this process of transferring from one agent to agent, another agent. Also, a communication mechanism of passing data context user input through from one agent to the other agent. So we're gonna take some time later today to talk about to break down those process and communication mechanism and more. But then I would like to talk about an actual way to implement it. And just about a week ago, and OpenAI released Swarm, public announced it. The repo is already there that a few months ago, and but you can see that this is when they make an announcement and should shut up to 15K star. And so, but then a disclaimer about this tool is that it is marketed as the what is this called, educational tool. It's not meant for production. That you can see the warning message at the top of the GitHub repo. And this is true. It's actually a very good learning tool. I realize. And so and the Swarm and the Swarm bunch of bees, and each perform very simple stuff. And so this is a sample code that you have that they have on their GitHub. But now I've shown you this template that we've been working with and trying to uh, understand the design process of an agent, a multi-agent system. Now I can do some interesting exercise that could you find a mapping between the implementation or this like hand sketch, high level hand sketch of the agent design. So it turns out quite easy. So you can see that to define the agent here, and then you pick the name agent A. So I put agent A here, and then you are a helpful agent. So I can write down here, you are a helpful agent. So that's where I write the role of this agent. And then we have this function, transfer to agent B, and I'll put it here, transfer to agent B. So that's how I will understand and process this example code. I'm going to repeat the same process for the next agent, agent B. So this might be, and then there's only speak in haikus. So I will write down the definition. So you are the speak. So speak is, well, speak haiku sounds more like a command. So I like to write in the more like a agent, a person. So I'll say you are a haiku speaker. So there's a person. Okay, sounds like person. And then you have you don't have any function. So there's no function, no tool. That's it. And very simple. And then we look at the message to the client to actually run this. So you have a user here, a role user. So I can draw a user, and to start this agent is saying the content. I want to talk to the agent B. So you will start with agent A. Okay. So then that is equivalent to what we see before. This user saying to agent A, and what is it? I want to speak. This what I want to speak. Speak to B. And imagine you send all this to a large language model. What would the large language model say you should do? Large language model will say, well, let's transfer to B. Okay, so this is how that I could analyze this code using this tool of this graphical hand sketch tool. And it can also work in the opposite way. Suppose you actually design the agent using this template at a high level, and then when you actually, in fact, you want to write the code in Swarm, then you can do the opposite direction. So now you define, I would like to have this is all based on the actual example that I found on the Swarm GitHub repo. So you want to define a user interface agent. So you write this onto a name field, user interface agent. And then you also could, well, and provide some instruction over here. So that's how you populate it. Of course, in real life example, you write a bit more. And you also have a function that you will just put into this array. Similarly, for next one, OpenAI Help Center agent. So you'll write down into the instruction over here, you are the OpenAI help agent. And then for the function, it's 3 of this. And then they're all mapped to, actually, it's not what I do. This is prettier this way. I can map this into an array into this array. Okay, so you can see the correspondence going back and forth. This help you sort of like have a high level sketches about designing your agent. So Swarm is pretty simple, very simplistic, and but help you kind of get a good feel of what the more basic multi-agent system. And when you're ready, you could use a more advanced system such as CrewAI. And so when I learned about this, I think I learned about Crew about like April. Now we are October, and now they have 20K star, and they just got 18 million Series A funding. That's getting pretty serious. So that's how I thought I could use this as an example to talk about some more advanced AI agent concept and techniques that beyond the simple swarm. And so let's think about this is a actual code also from the CrewAI. And as you can see, the prompt, this is a prompt you write to define the agent. It's a bit more complicated now, but still not too complicated because you can still map them using this template. So you will say that they define a role. So for instance, let's go here. So you want to define a researcher, okay? And then you should have role and goal and backstory. So there's a prompt. And then on the right-hand side, so I know, well, my agent one is a researcher. And then all the role and goal and backstory, you can just feed this over to this block. And then when you, and okay, and then, and for the next agent, defining a set of agents, we have reporting analyst. So it's just gonna write an analyst here, or another analyst. And then it has a role and goal and backstory. Then I know this is going to O, just feed right this in this block. And the next is to figure out what kind of action that I like them to do. And so, and then we read, and then there's a different file they get to write that define the task. In this case, the first task is a research task, and then the agent that run this task is researcher. So I could put this research task over here. So this is one of my tools, and there could be other tasks too, but not in this file. I didn't show in this file. And another task is reporting task. Who can do this task is reporting analyst. So with this information, I will continue to develop this. So I will say write report is not the task. Okay, so this is like a task that's trying to separate the definition of this task and tool into this separate YAML file. And nice thing about this is that you could work together with your other team members who may be more on the business side rather than on the coding side. You can work on this definition of the agent together in a less intimidating manner because because they don't have to see the Python code. But you are going to see some Python code just in a second. All right. So this is how in CrewAI you define agents, and you also define tools or functions that are kind of used interchangeably here, or tasks. But now we're going to talk about process, the breakdown of process. So I'm going to talk about some of the typical process. So when we look at these multi examples, so this process refers to the way that we transfer control from one agent to the other agent, like this. And the most basic pattern is the sequential pattern that was in use in Swarm, and they can support it by CrewAI as well. And the idea is we have a start with an agent. If we decide that, well, I'm going to transfer to B, so we're going to add to B, and then B maybe transferred. Decided, oh, now maybe I can look up some information. Then I eventually transfer to C, and then D transfer to D, and then the D could decide I can transfer to A again. So this is going through as a list or a loop sequentially. And each time you have one agent running, but once it's done, it hang off to the other one. So it's sequential. And the advantage of this is that that is a lot easier for us you to reason and to understand and to describe the process. And then a slightly more complicated would be to bring in hierarchy into this process, and CrewAI support this hierarchical process that would arrange them more like a tree, and it mirrors a lot of company organization as well. So we have a special agent called manager, and then this manager doesn't perform any specific task other than just tell other people to do stuff. Right? Tell transfer to delegate to A, delegate to B, delegate to C. Have A, B, C, three agents. So when delegate to when A is done, come back to manager, and then manager can decide, okay, now I want to delegate to C, and now I want to delegate to B. So there's a hierarchical. One person decided which agent need to be engaged. And so they could look at some code when they, but in this open source, I like open source because I can read their code, understand how exactly they might implement the particular function. And so in this case, I found this piece of system prompt that can tell you that, well, hierarchical manager agent. So the role is a crew here. You can see that, oops, let's erase this. The role is crew manager. So what by crew, you are the crew manager. And then you will have a go and backstory here. And then this all will be inserted into this one. But what's interesting is that if you read this more carefully, you'll say, well, your ability to delegate work to the right people and to ask the right questions imply there are two task is performed. In the backstory, even explicitly mentioned that you could delegate, you can also ask the right question so that there's two of these functions. So when you read the source code of how a manager is created, then you'll see down here, you have a manager object, you have a role, goal, and backstory that's retrieved from I-18. So there's an internationalization effort going on there. And all this will be used to populate this part to the definition, description of this agent, manager agent. And then have this line, well, I get all the agent tool, all the tools, from all the agents. So supposed to have 3 agents under the manager's management. So we'll have the tool, we'll have A, transfer, delegate to A, delegate to B, delegate to C. This is an array here. A, B, C. And also asking question A, asking question B, and asking question C. Okay. All right. So there's so it's kind of like a function call or procedure. So with a subroutine, you call subroutine, you don't expect the answer, but you make a question is a function call. You call A, but you expect the answer. Except that because we're talking about multi-agent, we don't want to use programming term like function. We tend to use question answering or delegation, the more like human. And so, and then going from hierarchical, you start to see that, well, there are even more complex process. It's kind of hard to manage, can't describe in the hierarchical manner. So you'll introduce, what if A want to transfer to B, and B, you want B to transfer to C, and you want C to transfer back to B, you want the B to transfer to A again, and then before, wait, this is table H. Before C, okay, C back to B, and B back to A, and before going back to the manager. Okay, so that's like a very arbitrary graph you could define beforehand that work for your business process. You start to see example like graph. So in terms of process, you can see that the most easiest will be the sequential one here, like list and loop, or like tree, or like a graph. Okay. And let's talk about communication. We looked at this example of communication. Where does communication happen? Is this relationship? What are other patterns that they can be used? We have seen. So one going back to swarm, we have a linear sequential process that one after the other. But when that happens, the one really natural way to communicate between the agent is do a code handoff. Basically, is we start with that when we are passing from A to B, for instance, I will pass all the context down to the next one. And then in this case, maybe I don't have anything. But for B, maybe first we look at this action being triggered. So this question to look up something from a database and get some extra context. And then second round, the context here. And then we pass on to C next. And after pass on C, this get copy over plus. And then let's use different color. In this case, maybe it triggers another database looked up into a different database and to look at something. There's a triangle. And when C transfers down to D, you just pass along, keep passing as you accumulate knowledge. So in this case, this get copy over. So what do we get copy over? What get copy over is this and this. And then in this case, you could continue this process. Maybe now I look it up, running out of color. So this and looked up from my database and come back to something, maybe look on X. So this just keep passing off. Everything you have just pass to the next agent, and hopefully they'll take it. And in this case, the some property of this is kind of like is a stateless. So no one has to remember this because always just pass everything down. And the real world analogy is kind of like I think is kind of like when me, my wife, and a babysitter trying to all work together to take care of my son when he was really young. So then we have this notebook that to keep track of what he has eaten and stuff. And then we just pass the notebook down. Then and everybody remember, all like in the hospital setting, they have a chart, patient chart. Every shift, you have a new nurse, and this nurse will just take the chart that has all the information. So it's like a handoff that was implemented in Swarm, but it's the most basic way of communication between the agents. And then in CrewAI, you start to see the question answering. So in the technical term, you can think of you a programmer, you can think of it as a function code, but since we're talking about agent, we're trying to use human term. You don't use function code with your manager or for myself. I don't see my students as someone I just make a function code. I do a question answering. So in this case, when the A can say one was ask B, and then when B is being asked, and so this question being added into the input of not wrong direction. Okay, not here. Input of B, and then when B finally get the answer, and B will transfer back the answer to A. So there's a little function call. If C can also ask question of D, for instance, similarly, and when D is ready to return, oh, then draw this too. So they will return to C as a new input. So this is the relationship. So I have to come back. So the communication kind of happen in that questioning, answering, and responses. Questioning, you ask another, and then you get an answer back. You're guaranteed to get an answer back. And so, so the advantage of this is that function call is very easier for people familiar with making function call, especially you're a developer. Also, people are familiar with asking questions and getting answers, emailing a question to your colleague expecting an answer back. So it's very easy to reason. And then lastly was the messages that you will potentially put something in and other people will be listening as well. So there's another system that I've been seeing. For instance, I put this in and somehow B is listening to this, listen. And then when the messages sees that and B is engaged. So there's a way transferring messages, you have a shared message queue. So that's also quite common in the supported by CrewAI and some other multi-agent framework. All right. And then I kind of talk about a memory system. Another interesting concept is memory system. So suppose we have this exchange that will process refund and coming back in $15. And so, and then instead of having explicit communication between agents, sometimes you could put a memory, use a separate database to store memories. So for instance, in this exchange, a process refund and $15 back. This thing is a bit more like just immediate transaction. So we tend to put a short-term memory as is in the raw text, maybe embedded in the text embedding. So because of that, typically we use a baked database to store the short-term memory. But then in the long-term memory, if you would like the agent to continue to evolve and become better, So you could take this in the entire intersection and say, well, maybe we should evaluate this process, reflect upon this. Is this anywhere I can improve? And you can ask the large language model, it's pretty smart with logic to analyze this and telling that, well, I'll give you a quality score of say 7. And I suggest that just instead of saying just $15 back, why don't you be more polite next time? So this is the something that the legend learning. Where do you put this learning? Put in the long-term memory, and there's a bit more larger, and so you can put a SQL structure because quality and suggestions kind of like in the table. And then when next time agent B or agent B is agent A B engaged, they will be able to draw from both the short-term memory and also a long-term memory to use them and adding that to the context. So next time, so that how the agent can evolve and improve. So using this memory system. And you can see the implementation again that this is happening. So in the short-term memory implementation of CrewAI, and you will see that when you just basically save the output and also the description, which is what we have here, you save this into a short-term memory. And then we looked at the implementation of the long-term memory. You can see something similar here. Okay, so we have this long-term memory item, but let me see. So, and then you can see that you use the LM agent here to run evaluate, and then with text and output, text and output. And then as a result, then you store them, save them into, what do you get? You get suggestion and quality, which is why we have here suggestion quality. And then you save them into your long-term memory, saved in the long-term memory. So you can see the code actually implement this logic that it was a long-term memory that there because you like your agent, multi-agent, to learn from the system and become better on its own too. Okay, and so now I will going to talk about a few more even advanced example to apply some of the knowledge I've talked about. So first, I'm going to talk about open hands. So you might heard of Devin, which is from cognition AI, and like was what at the time was like they making a claim is the first software engineer based entirely on AI. And so in the group decided to open source this, so open Devin, and become really popular. And it is rebranded into Open Hands. And you can see that this is about it that's when open Devin happens, and then over time, then it becomes Open Hands. And so this is a legitimate system that lots of people use them, and they're trying to trying to act as software engineer, as a group of software engineers that handle different things. So there's a user interface, have a chat on the side, chat, and then you can see that all the action trying to do, and some view of the code that's being edited, and can also search the web, and then also produce some kind of report. So there's a whole trying to model the entire software engineering process with multi-agent system. And because open source, again, you can see the code, and it's a system architecture diagram that generously posted in the GitHub repo. And I have to say, it's pretty complicated and it's pretty scary to look at it. And would you like to study it? But then if you would just focus on this key concept that I was just going through, ask you that any agent system will have to define a bunch of agents. Multi-agent system define a bunch of agents. And you look at this diagram, it must be somewhere that defining a bunch of agents. So it turns out it's over here, this agent block. So you learn from, there's a whole bunch of agents here, and you can look at the code and read their system prompt and learn from it. And every agency has a process. In this process, you can see that, is this linear? Is this hierarchical? Turns out have a controller, has a manager. So you learn that, we have a manager, it's a hierarchical sort of process. And you have a communication mechanism. Is this handoff? Is this based on the messages or based on, so it turns out you look at event stream, so you know is this based on messages. Also not based on question answering. And you have a memory system. Do I use the memory system? So we have storage here. here. So there must be a memory system. They have a S3 is and local in memory, so it can kind of guess that this must be some kind of short-term memory. This is a long-term memory because of more like file storage. And then you can see how all this being added to an original LLM only scenario and to give you a multi-agent system. So if it's and this large language model here, so have their commercial model or their own open source models there. And they can practice this again with another one, colder, another pretty like a state-of-the-art system for resolving GitHub issue. So now you look at agent, you know the file of this, and then the process is, and it turns out, if you look at the process here, if a task graph, well, it's a graph system, and communication, how is communication done? Is a handoff? It is question answering. It turns out it's a kind of new way of doing writing reports. So it's similar, almost like Q&A, because the manager assigns something and they all write report back. And then does it have a memory? So it turns out I can't really find explicitly when they talk about a short-term memory and long-term memory. So maybe they don't evolve over time. So that's missing. And they have a large language model, which is implied. It doesn't really show this in the graph. And then, and even it worked out for a multi-agent model that this is a exercise for you. And then based on why, how, AI, they have multiple graph. They're trying to say having one large knowledge graph is not as good as having multiple smaller specialized knowledge graph, especially for legal. They can build from this document from this into this tree. And once if it's tree, you could have multiple agents here. So just work on agents. So have this user query, but you have this agent, definition agent, search agent, supervisor agent, router agent, retrieval agent, answering agent. So these are a multi-agent system. As a process, the process to me looks like obviously it's a graph system kind of going this. It's not doesn't follow a strict tree architecture or linear architecture. And communication is you could analyze how do they communicate. So it turns out they probably communicate through passing this graph. So here is passing this graph, subgraph as communication. And the memory is just stored in this graph database themselves and building upon large language model. Okay, so let's very quickly going through how apply how this, if you understand some basic concept, process, communication, memory, large language model, agents, that's another concept too. But then if you apply the same set of concept that help you going through multiple use cases and analyze the multiple framework, that how you can achieve and solve the particular business problem, model your existing business process, that help you succeed. All right. So at the end, remember you can download my slides, the same website. So because Single Store usually put the recording on YouTube, so I'll also share a link on that once the YouTube video is up. Question. Sorry, didn't leave much time. But we have a multi-agent system going on. Like Mal has been answering a lot of questions in the background. So it's neither sequential nor hierarchical. It's a parallel. So it's one pattern I did not talk about today.
Tom, there was a question about the slides, and forgive me. I mean, I downloaded the PDF version of your slides. I looked through them. To me, they look okay, but I think people were expecting animation in there. Was that the case or not?
Oh, animation will be in the recording. That is a practice slide that you could follow my
Yes, that's what I
animations.
thought.
Yeah,
That's
but
right. So
then
essentially, I mean,
eventually,
that's the
once
workbook
we
that you're
upload,
providing.
yeah. So once
Yeah.
I uploaded the video, then that would be you could be able to use slides and the video at the same time.
Oh, okay, great. Thank you. And I think there was let me just check. I think it was see who was asking. Josephine. Josephine was asking for real world examples. So I think you mentioned Swarm, for example, and CrewAI. So I think in the case of Swarm, I think you referenced the GitHub repo. I mean, the nice thing about OpenAI is that they do release these technologies on GitHub, and you can go and have a look at them. I've used Clip, for example, and I've used Whisper from GitHub. Awesome, they're free, they're easy to work with. But I think the question was really, do you have some examples of real world, uses of these?
So today I share a few real world example, and OpenHand is probably the most complex one, and they have entire open source repository. You can just check each file and learn from the way they write prompts and how they coordinate and stuff. And so this is a bit more application because it has a actual application of fixing writing software and addressing search in the web. And CrewAI is more of a framework, and it could be applied to a real world example. Maybe some other repository have used CrewAI. So when you study CrewAI, it helps you understand the framework. How does a general framework support
Yeah.
many different use cases of CrewAI? And so there's two different directions you could study and to see whether it can apply to your particular use case. And Swarm is again educational. You only support handoff and also sequential process and handoff for communication. But because it's also small enough, a lot easier for you to swallow and understand and process to help you build foundation. So I also encourage you to check Swarm to build the technical foundation before you extend your multi-agent skill to using a more advanced framework.
Yeah, there's a great question here from Kiran. Asks, what if the agent encounters failures? It says here, looks like covered mostly the positive scenarios. I assume there is error handling, escalations, etc. Yes, of course. But did you have some thoughts on that, Tom? Any ideas about how the
So
different...
in Swarm, CrewAI both have a section that talk about how they provide some evaluation. So they could provide some test cases. For instance, each of these task and description, and there's another field called expected outcome, and so they could be used to test it. And if you don't pass those expected outcome, the model itself is smart enough to make suggestions as well. That's where the memory comes in. It was able to learn to fix it and then go back to go into long-term memory, and maybe then will be something more like extra prompt get added automatically. For instance, be polite, be more precise, cite the references, and ask user for clarification. Those could be added in part of your long-term memory build-up process. But again, there's another aspect we did not talk about is the cost, because you can see that this whole thing needs to be fed into your large language model. You better have lots of OpenAI API credits, or you run your own model. So multi-agent can be expensive too to run.
Great. Thank you very much for that, Tom. Yukti, I'll hand back to you because we are at the top of the hour, and I guess half past where you are in India, so probably time to wrap up.
All right. So thanks everyone for joining. And if you have any other questions, feel free to reach out to us at team@singlestore.com, or you can also reach out to me or Akmal via LinkedIn, and we'll try to take care of whatever questions you have. Also, if you have any feedback, any ideas on topics that you would like to see in future sessions, please feel free to, just let us know, and we'll try our best to cater to that. And if you're interested in the future sessions, I have put it in the chat. You can attend. We are on October 28th, we are presenting Build with Node.js on SingleStore. And on October 29th, we are presenting Building a Full Stack Next.js AI app. And tomorrow, we are actually presenting a joint webinar with Hasura, and that webinar caters to agents. So if you like today's topic, feel free to tune in tomorrow, and really appreciate everyone joining here. Have a great rest of the day. Thanks, Tom, for joining, and we really appreciate that you took out the time to do this webinar with us, and we're hoping to do more in future. All right.